Hello everyone, Grayson and I did basic facts and whole numbers. What are basic facts? In addition and multiplication, basic facts are number combinations where both addends or both factors are less than 10. For example, 7 plus 2 equals 9 is a basic addition fact, or 6 times 2 equals 12 is a basic multiplication fact. Basic facts for subtraction and division are the corresponding combinations. So 15 minus 8 equals 7 is a basic subtraction fact, or 15 divided by 3 is a basic division fact. Basic facts and Common Core State Standards. Common Core State Standards suggest that basic addition and subtraction facts should be learned by the first grade, and quick recall of those facts should be mastered by the end of second grade. Curriculum focal point implies that multiplication and division should be learned in third grade, and quick recall of one-digit facts should be mastered in grade 4. Common Core State Standards suggest one-digit facts should be known by memory by the end of third grade, so there is a little bit of a discrepancy between the two. Basic fact development. Developing quick and accurate recall of the basic facts is a developmental process. There are 3 phases in this development. Phase 1 is counting strategies. Students use objects such as fingers and manipulatives, or verbal counting like counting on, to determine the answer. In Phase 2, they use reasoning strategies. Students use known information to determine answers. For example, when figuring out 5 plus 6, students know 5 plus 5 equals 10, so 5 plus 6 is just one more. Phase 3 is mastery. Students produce answers quickly, accurately, and efficiently. Students just know it, so 4 plus 5 equals 9. They have quick responses. Approaches to fact mastery. There are 3 different ways that attempt to help students master their basic facts. 1 is memorization, 2 is explicit strategy instruction, and 3 is guided invention. Memorization. It's also known as the passive storage view. Some textbooks and teachers move from presenting concepts of addition and multiplication straight to memorization of facts, feeling that developing strategies is not essential in this process. For this approach, students must memorize 100 separate addition facts, just for combinations of 0 through 9, 100 separate multiplication facts, and 100 or more subtraction and division facts. That's over 300 facts that have to be memorized. This approach also has limitations. It's inefficient as there's simply too many facts to memorize. It's inappropriate application as you can misapply facts and you don't have to check your work. And it's inflexible, so you don't learn flexible strategies for finding sums, it's just memorizing. This approach can cause unnecessary anxiety and can undermine interest and confidence in math. Research suggests that there is strong evidence that this approach is ineffective. Explicit strategy instruction. This approach focuses on explicitly teaching efficient strategies that can be applied to a collection of basic facts. This approach can be effective. It is intended to support student thinking rather than give the students something new to remember. The key to this approach is to demonstrate various strategies to solve basic facts so that students can see all the possibilities and choose strategies that will help them get to the solution without counting by ones. Guided invention. Fact mastery in this approach is connected to students' collection of number relationships. In this approach, students use number combinations and relationships to make sense of basic facts, so they use what makes sense to them. So for example, some students may think of 7 plus 8 as double 7, which is 14, and one more, which is 15, while another student may note that 8 is 2 away from 10, so they take 2 away from the 7 to put with the 8 to make 10, so that the problem becomes 10 plus 5. The teacher's job in this approach is to design tasks and problems that will promote invention of effective strategies by students and to ensure the strategies students invent are clearly articulated and shared. Strategy development. In order to guide students in using effective strategies when solving basic facts, we must command as many successful strategies as possible. We need to plan experiences that help students move from counting to strategies of recall. Story problems and reasoning strategies are 2 effective approaches. Language supports understanding. This statement is part of why story problems are an effective approach to solving basic facts. Story problems also help students to understand the situation and apply flexible strategies for doing computation. Reasoning strategies. There are many reasoning strategies for basic facts. Each strategy should be clearly modeled. With this approach, students need lots of opportunities to make the strategy their own. Therefore, strategies should be modeled more than once, and students should have many opportunities to practice reasoning strategies. The big idea behind using reasoning strategies is for students to make use of the known facts and relationships to solve unknown facts. When teaching these strategies, it's a good idea to write them on the board or create posters for each one. Let's take a look at reasoning strategies for addition. They are 1 more than and 2 more than, adding 0, using 5 as an anchor, make 10, up over 10, doubles, and near doubles. Let's look at the strategy 1 more than and 2 more than. There are 36 facts with the add-in being either 1 or 2. Often when children count, they don't reflect on the way one number is related to another. Students need to be encouraged to notice and describe parts of numbers and look for relationships among the parts. In order to teach 1 more than or 1 less than, the teacher should demonstrate counting on or back 1 or 2 counts. Story problems are also great ways to teach this strategy. For example, 7 children were waiting for the slide. Then 2 more children got in line. How many children were waiting for the slide? Some students may solve this problem by counting each child, which is phase 1. Some may start counting from 7, which is phase 2, while others will just know that 7 plus 2 is 9, which is a phase 3. Helping students to see the connections between counting on and adding to will help them to move from counting strategies to reasoning strategies. The strategy of adding 0. There are 19 facts that have zeros as one of the add-ins. Students often overgeneralize the idea that answers to addition problems are bigger than the add-ins. To teach this strategy, you could use word problems and drawings. Writing 0 facts on the boards, some with 0 first and some with the 0 second, will also be helpful for teaching this strategy. This strategy is using 5 as an anchor. Using an anchor such as 5 or 10 builds on students' knowledge of number relationships. This strategy is a great way to reinforce number sense and learn the basic facts. To use this strategy, students must be taught to look for 5s in numbers in the problem. For example, 8 plus 6. Students would need to see that 8 is 5 plus 3 and 6 is 5 plus 1. From there, students would add the 5s and then the extra 3 from the 8 and the extra 1 from the 6, adding up to 14. A tens frame, such as the one below, can also help students to see numbers as 5 and some more. The Make 10 strategy. This strategy helps with basic fact mastery and builds the foundation for working on addition with higher numbers and understanding place value concepts. According to the text, Make 10 strategy is perhaps the most important strategy for students to know. In order to use this strategy, students must recognize that one number is contained in another number. They need to chunk numbers rather than think of them as a collection of units. In this strategy, students find and use number combinations that make 10. The best way to teach this strategy is to use story problems that use 2 numbers to make 10, such as, if I pick 6 red apples and 4 green apples, how many apples do I have in all? Or story problems that ask how many are needed to make 10. I have 10 pigs that I need to give a bath to. I've bathed 4 of them, so how many more still need a bath? The tens frame can also be useful for this strategy for creating a visual image. Up and over 10 is another reasoning strategy. It can also be known as the break apart to make 10 strategy. Facts that have sum greater than 10 can be solved using the up and over 10 strategy. It is considered the most useful strategy, especially considering that the toughies for students tend to be those that have sums over 10. Again, students need to recognize that one number is contained in another number and be able to chunk the numbers. For this strategy, students use their known facts that equal 10, then add the rest of the number onto 10. For example, when solving 7 plus 8, students would notice that 8 is 2 away from 10. They therefore take 2 away from 7 to get 10, and then add the remaining 5 to get 15. So you'd look at the problem now as 10 plus 5. This strategy aligns with previous experiences with the tens frames. Alright, let's look at doubles. There are 10 double facts from 0 plus 0 to 9 plus 9. These facts are often known by students because of their rhythmic nature. Doubles can be anchors for other facts. Story problems can be helpful for teaching doubles, as well as creating a double machine in which cards are made with an input number on one side and the double of that on the back. The card is flipped as it goes through the doubling machine, such as the one below. Near doubles, also known as doubles plus 1 or doubles minus 1. There are facts where one added is one more or one less than the other. So for example, 6 plus 7 or 4 plus 3. In this strategy, a known fact derives an unknown fact. The strategy here is to double the smaller number and add 1, or double the larger number and subtract 1. This strategy can be taught by writing near double facts on the board and having students solve them independently. After they solve them, discuss the students' strategies. Write the corresponding doubles on the board and ask how these facts might help to solve the near double facts. This is a more difficult strategy and is harder for students to recognize. Remember, with all these strategies, don't force it on the students. They'll figure out which ones work best for them and use the ones that work best. Reasoning strategies for subtraction. Subtraction facts prove to be more difficult than addition facts. Without reasoning strategies, students continue to rely on counting strategies to come up with answers. Reasoning strategies for subtraction include subtraction is think addition, down over 10, and take from 10. Let's take a closer look at each. The first strategy is subtraction as think addition. For this strategy, students use known addition facts to produce the unknown quantity. To teach think addition, look at the example below, 13 minus 5. Students can count out 13 manipulatives and cover with a cloth. They would then remove 5 manipulatives. They would have to think 5 and what makes 13. They should conclude that 8 plus 5 is 13. 8 manipulatives should be covered. Story problems are also beneficial for this strategy. Story problems that promote think addition sound like addition story problems but have a missing add-in. For example, I have 5 pet spiders. I found some more. Now I have 9 pet spiders. How many spiders did I find? Down over 10 is another subtraction reasoning strategy. Again, students use what they already know to figure out a related fact. In this strategy, students count down to 10 and then down more to find the total difference. Look at the problem below, 14 minus 9. To solve this using down over 10, students start at 14 and count down to 10, which is 4. And then count down 1 more to 9 for a total difference of 5, because 4 plus 1 is 5. To develop this strategy, write 5 pairs of facts in which the difference for the first fact is 10 and the second is 9, so 17 minus 7 and 17 minus 8, and so on. Have students solve and discuss these strategies. If students don't see the relationship, ask how the first fact helps solve the second. 17 minus 7 equals 10, 17 minus 8 equals 9, 17 minus 9 equals 8, 17 minus 10 equals 7, and 17 minus 11 equals 6. Reinforce this strategy with a story problem. The last reasoning strategy for subtraction is take from 10. This strategy is not commonly used in the United States, but is consistently used in high-performing countries. This strategy takes advantage of students' knowledge of the combinations that make 10. It works for all subtraction problems in which the starting value is more than 10. Take the problem 15 minus 6. Take the starting value apart, 10 plus 5. Next, subtract the second number in the original problem from the 10, so 10 minus 6. Add the total back to 5 and you should get 9. This strategy may seem uncomfortable at first, but it is a great reasoning strategy to use. Reasoning strategies for multiplication and division. It is imperative that students completely understand the commutative property. Seeing how the commutative property works is more effective than just learning related combinations as turnaround facts. Understanding this property cuts the basic facts to be memorized in half. The reasoning strategies for multiplication and division are listed below. They include doubles, fives, zeros and ones, using known facts to derive other facts, and division facts. The first strategy is doubles. Facts that have 2 as a factor are equivalent to addition doubles and should already be known, so 2 times 6 is the same as 6 plus 6. In this strategy, students should realize not only that 2 times 6 is the same as double 6, but is the same as 6 times 2. As with many of the reasoning strategies, word problems are a great way to teach doubles. Word problems should include 2 sets, such as Sarah has 2 collections of stamps. In each collection she has 6 stamps. How many stamps does she have in all? Fives is another reasoning strategy for multiplication. This consists of all the facts with 5 as the first or second factor. To teach the 5 strategies, students should practice skip counting by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Connect counting by 5s with arrays that have 5 rows of dots. So below are some arrays, the 5 by 4, a 5 by 2, and a 5 by 6. Zeros and ones. 36 facts have at least one factor that is either 0 or 1. Though apparently easy on the procedural level, these factors tend to get confused with the rules that some students learned for addition, and I can see how this can be confusing. In addition, when a 0 is added, the sum is equal to the other added. But in multiplication, when one factor is 0, the outcome is always 0 regardless to the other factor. It is best to develop these concepts through story problems. It can also be helpful to teach students how to put words to these equations. For example, when completing 4 times 0, say aloud, there are 4 groups with 0 items. Or for 0 times 6, say aloud, there is 6 in a group but there are 0 groups. Nifty nines is my favorite multiplication reasoning strategy. Even though factors of 9 include the largest products, they can be the easiest to learn. To solve factors of 9, there are multiple strategies that can be used. First, students can derive that 7 times 9 is the same as 7 times 10, less one set of 7, or 70 minus 7. This idea can be introduced using base 10 blocks. Second, a table of 9 facts creates interesting patterns that can lead to finding products. For example, the tens digit of the product is always 1 less than the other factor, or the factor that is not 9. So 9 times 6 equals 54. So 1 less than 6, which is the other digit, is 5, so you know that the answer is going to be 50-something. Or for 9 times 8 equals 72. 8 is the other digit, so we know that the product's going to be 70-something because 1 less than 8 is 7. The sum of the two digits in the product is also always 9. So for the same examples, 9 times 6 equals 54, 5 plus 4 equals 9, and for 9 times 8, which equals 72, 7 plus 2 equals 9. For students to explore and discover this pattern, ask students to record each fact for 9 in order and write down patterns they notice. Another way to remember nines is a tactile way in which you use your fingers. Watch the video that follows.
Show you how to multiply. In this video, I'll show you how to multiply by the number 9 using only your fingers. This is a very simple method, a fun, visual way to multiply by 9, especially for children. As a first example, let's look at 9 times 3. We'll start with our left pinky and count along our fingers to 3. 1, 2, 3. Next, we'll count the number of fingers to the left of 3. There are 2, so we will put a 2 in the tens place. Now we will count how many fingers are to the right of 3. There are 7, so we put a 7 in the ones place. So our final answer is 27. It's that simple. Let's do another example. Let's find 9 times 5 using only our fingers. We start with our left pinky again and count across to our 5th finger. 1, 2, 3, 4, 5. Then we count the number of fingers to the left of the 5th finger. There are 4, so we put a 4 in the tens place. Next, we count how many fingers are to the right of the 5th finger. There are 5, so we put a 5 in the ones place. So our final answer is 45. Now it's your turn to try this method. Try solving 9 times 7 in 10 seconds. Time's up. Did you get it? There are 6 fingers to the left of 7, and there are 3 fingers to the right of 7. So the correct answer is 63. Cool, huh? For more cool math,
Using known facts to derive other facts is another reasoning strategy. The remaining 25 facts that have not been learned so far through these strategies can be learned by relating them to already known facts. Students should be taught to go to a fact they know that is close and then add however many more sets to the known fact to figure out the unknown fact. For example, students should know that 6 times 6 is 36, so 6 times 7 is just one more set of 6, so it's 42. Creating arrays for these facts can also be a powerful tool. This strategy has no limits. It can be used for any multiplication fact. This strategy reinforces students' sense of number and relationships between numbers. Division facts. Mastery of multiplication facts and connections between multiplication and division are key elements of division fact mastery. For example, to solve 40 divided by 8, we tend to think 8 times what is 40. Because we think of division like this, the reasoning facts for division are to think multiplication first, then apply a multiplication reasoning fact. Basic facts. The big idea. Developing reasoning strategies helps students move away from counting to becoming more efficient in recalling facts. Common Core state standards state that students will know from memory their facts. This is not a result of hours spent memorizing, but rather a result of repeated experiences with reasoning strategies. Remember, there is no single best strategy. The more we emphasize choice, the more students will be able to find strategies that work best for them. Okay, so here's the activity. Let's practice using our reasoning strategies. Solve the following using the specified reasoning strategy. So the first one is 5 is an anchor, using a tens frame for 7 plus 9. Next is up over 10, using 9 plus 4. Near doubles, 6 plus 5. Down over 10, 16 minus 9. Take from 10, 14 minus 6. Doubles, 2 times 8 equals blank plus blank. 6 times 2 equals blank plus blank. And 4 times 2 equals blank plus blank. Fives, draw an array for 5 times 4. Nifty 9, use the finger method to solve 9 times 7, and using known facts to derive other facts for 8 times 6. I'd pause the video here while you work on this activity. Alright, so let's go over the answers to the activity. Using 5 as an anchor, using tens frame for 7 plus 9, you should have drawn something similar to what is being displayed. For up over 10 for 9 plus 4, 9 is 1 away from 10, so you take 1 away from 4 so that the problem becomes 10 plus 3, and it should equal 13. Near doubles, 6 plus 5. So you should use what you know, so I went with the known fact 5 plus 5 equals 10 and added 1 more to get 11. Down over 10, 16 minus 9. So you start at 16 and you count down to 10, which is 6. Then you count down 1 more to 9, which is 1. 6 plus 1 equals 7, therefore 16 minus 9 equals 7. Take from 10, 14 minus 6. 14 equals 10 plus 4. 10 minus 6 equals 4. 4 plus 4 equals 8. Therefore, 14 minus 6 equals 8. For doubles, 2 times 8 equals 8 plus 8. 6 times 2 equals 6 plus 6. 4 times 2 equals 4 plus 4. So for fives, you should have drawn an array similar to the one being shown for 5 times 4. Nifty nines, you should have had 6 fingers on the left side and 3 on the other, so that 9 times 7 equals 63. After using your fingers, did you check to see if the tens digit in the product was 1 less than the other factor? Was the sum of the 2 digits in the product 9? And then using known facts to derive other facts, 8 times 6. So I know that 8 times 5 is 40, and 8 more is 48, so 8 times 6 is 48.